Here in this example, we will see this two span ABC. The deflected shape must pass through the supports and downward deflection under the load. These are the support points, and this is the downward deflection under the load. So it should pass through like this. Note that a structure will always deflect in the direction of the load provided that is only the force acting on it. And the smooth curve shows the change of curvature. This and this, it shows the change of curvature characteristics of multi-span beams. That means in the change of curvature will happen in the multi-span beams. This is one of the characteristics. The direction of vertical reaction at C. May be identified by imagining the reaction is removed. Suppose if we remove this one, what will happen? This would deflect like this. So the function of this reaction is to bring it down. So it will come to the downward direction only, because it is not going to move. It will be the same position only because its deflection is 0. So it has to come down, then only it can meet this position. The beam would deflect upwards on the direction of the reaction. Necessary to bring them back to the correct position would be downwards. Both VA and VB act upwards. As the first lines of bending moment diagram may be drawn from the consideration of the effect of upward reaction at A producing tension on the underside of the beam. If it moves up, then it will produce the tension at the underside of the beam. And the downward reaction, this downward reaction producing tension on the upper side of the top of the span. So it would come like this, and it would come like this. The bending moment diagram is completed with the straight lines between the load and point B. Between the load and point B, it will be the straight lines. And the coincidence of the zero moment at the point of contraflexion may be now recognized and checked. Coincidence of zero moment and point of contraflexion. This is a point of contraflexion having zero moment. Here, this analysis 3 span beam would proceed in a similar way. The first step is to identify the points of certainty on the deflected shape. We have to identify the points of certainty. This point is 0 deflection, 0 deflection, 0 deflection, 0 deflection. This point, it would move downward. These are the points of certainty on the deflected shape. The beam must pass over each of the supports and deflect downward below the load. A smooth curve may be drawn between these points, and the direction of vertical reactions is identified by their notional removal. If I remove it, what will happen? It will come like this, so we have to push it up. So the reaction D must act upwards, and this, if it will come like this, so it should come downward. VC should reaction C downwards. The first most obvious points on the bending moment diagrams are usually those at each end of the beam. So at each end, this will deflect up, so it's a tension on the underside. This will deflect up, tension on the underside. Here the upper reaction at A and D both produce bending tension on the underside of the spans AB and CD respectively. AB and CD respectively. Then to complete the bending moment diagram, you must be able to identify the fact that beam is hogging over the supported B. At B, it is hogging over. It is hogging over like this. At B, here you can see it is hogging over. Note that this beam has 2 points of counterflexure. This here 1 point of counterflexure, here 1 point of counterflexure in the span BC. Note the identification of these areas of bending tension on the diffraction shape and visual check against the bending moment diagram. Tension here, tension here, tension here. This next example is a 3-span beam with fixed support at A. 1, 2, 3. 3-span beam with fixed support at A, loaded at the central span BC with W load W. Note the beam must enter with fixed support A with 0 deformation compared with unloaded structure. At A, there will be a 0 deflection and 0 rotation. And failure to draw this clearly is the common source of error in drawing the deflector shape. Because the bending moment is drawn in the tension side of the deflector shape, we should check always be made between the deflector shape and bending moment diagram. To facilitate this check, identify areas of bending tension. The reactions are determined by their notional removal from the deflector shape by their notional removal. The most obvious lines of bending moment diagram may be now drawn. The sagging moment at A. So because of this load, what will happen? It will go up, and this will also go up. This will push it down, so it will come like this. Once it's going like this, it will go up, but we have to bring it down, but 0 deflection. So here tension comes at the top, bottom side, here top side. That's the reason it's coming like this. Note that it is known that the line of bending moment diagram from A, it will move across the baseline because this moment is clockwise, this is anti-clockwise. So this tension is bottom side because of this clockwise moment. It will reduce it. That's why it goes like this. This comes like this bottom side and it goes like this. And between these points, it's connected with straight lines. Bending moment diagram may be completed with the straight lines as there are no other loads between these identified points of the bending moment diagram.